Okay, let's get started. This is Mark McHenry with Morningstar, and I'd like to welcome everyone to the webinar, Off-Grid Solar Power for Traffic Management. This is a joint webinar between SunWize and Morningstar. Let's go ahead to the next slide that displays the GoToWebinar console. There's a couple things I want to point out on this slide. We've attached a copy of today's presentation in the handout section of your GoToWebinar pane, and we suggest that you click on that and download it right now. During the presentation, we encourage you to click on the questions chat section and text in any questions that you have. We have a number of SunWize application engineers on the line with us that are going to help to field questions. So yeah, you definitely don't want to miss out on that. Any questions you have, feel free to type them in and we'll address those at the Q&A session at the end. Should also mention that we're recording this broadcast and you'll receive an email tomorrow with a link to the recording. And with that, let's go ahead and talk to this agenda slide. So we'll share some background info about Morningstar and SunWize. I'll cover what you need to know about the solar charge controllers that are used in off-grid traffic applications. And then I'll hand off to Errol Rankin, who will do the bulk of the presenting today about the different types of off-grid solar traffic management applications and the effect of the new infrastructure bill. He'll also cover electrical loads, wind speed ratings, and certifications. And before the Q&A, he'll discuss remote monitoring and traffic enclosures. So with that, we can take a look at some info about Errol Rankin and myself. So you see Errol Rankin on the left. He's a VP of Sales and Technology for SunWize, and I'm a marketing manager with Morningstar. We've done several joint webinars together, but this is the first one we've done about traffic management applications. There's a trend for more signals, lights, monitoring, and digital traffic signs, and off-grid solar is being used more and more to power those loads. All right, and you see the Morningstar slide up here. I just wanted to share some quick information about Morningstar. Morningstar is a US company that has provided over 4 million solar charge controllers and inverters for mission critical applications all over the world since 1993. We're considered to be the charging experts with the widest product line and lowest hardware failure rate in the industry. And in addition to traffic applications, Morningstar products are used in telecom, oil and gas, security, lighting, residential, and many other off-grid solar applications. Let's talk about the solar charge controllers that are used in traffic management applications where no electric grid is accessible and signals, lights, and signs are all run by solar-powered batteries. So if we take a look at the next slide, we're going to look at the purpose of the solar charge controller, which is to receive DC power from a solar array and to convert that power to proper voltages and current to run loads and charge batteries during the daytime, and then to let the batteries run the loads during nighttime when there's no sun. The charge controller prevents batteries from overcharging and undercharging, and it also provides load management. A good controller can extend battery life for many years, and a poor controller can destroy batteries and cause your entire off-grid system to fail. And this slide illustrates a system that is charging DC loads. And on the next slide, we'll show you a system that powers loads that run off of AC power. So in this diagram that you see now, you can see that an inverter has been added in the lower right. And the purpose of the inverter is to convert direct current or DC power into alternating current or AC power. Some traffic systems have loads that require AC power, but many don't. And sometimes people unnecessarily convert a system to AC power and add inverters and efficiency losses to a system that could have been deployed as a DC system without an inverter. And Errol has seen some examples of this. That said, I'm going to stay on the charge controller topic and go to the next slide to cover some of the features and protections associated with solar charge controllers. Now, depending on your application and the types of batteries that you're using, you may want to use a controller that has programmable charge settings. For example, the ProStar MPPT controller on this slide has interactive scroll buttons that allow you to change absorption and float voltages and times according to battery manufacturer specifications. Some controllers have load control, otherwise known as low voltage disconnect or LVD. This feature disconnects the battery from electrical loads when a battery's voltage dips below a set threshold. This is important if you want to make sure that your batteries don't over discharge, which can kill batteries and render them useless over a short period of time. Some controllers have lighting control, and this is very important in traffic applications. If you have a situation where you want to program lights, signals, or digital signs to turn off and on during certain times during the day and evening. And in terms of heat dissipation, it's advantageous for a controller to have a fanless cooling design to dissipate heat. Conversely, controllers with fans suck in dust and debris over circuit boards, which compromise performance. Fans can also be noisy, they're a parasitic load, and they represent another point of failure. So all Morningstar controllers are fanless with passive cooling. Charge controllers in traffic systems have to be reliable and able to withstand transport and all types of weather conditions. So they should have a 5-year warranty and a strong track record for life expectancy well beyond that 5-year warranty. Some traffic management applications associated with chemical spills and gas leaks may warrant controllers with hazardous location ratings, so you can check data sheets for those specifications. And then lastly, some applications may warrant solar charge controllers that can support oversized PV arrays. So that kind of takes you through some of the features. Now we'll talk about some of the protections on the next slide. In terms of protections, we recommend charge controllers that have automatic recovery without fuses, so you don't have to manually replace a blown fuse to start your system back up when conditions are favorable again. That's very important. Controllers should have transient surge protection to protect against nearby lightning strikes. They should also have overload, short circuit, high temperature, reverse polarity, and nighttime reverse current protection. And if you're using lithium batteries in a potentially cold environment, you might consider a controller that has a low temperature fallback provision, which decreases and eliminates charging when battery temperatures reduce to levels that can result in damage to batteries. All right, so let's go ahead to the next slide. We'll take a look at the 2 different types of solar charge controllers that Morningstar offers. The 2 major types are pulse width modulation, or PWM controllers, and the second is maximum power point tracking, or MPPT controllers. MPPT controllers use a newer technology. They're more expensive than PWM controllers, but they provide more power to run loads and to charge batteries, especially in colder climates. They also support oversized PV arrays, and they can be used with 60-cell modules, which are often not suitable for PWM controllers. On the next several slides, we provided some charts that list the most popular controllers for traffic management applications and some of their most important specifications. So what you see on this slide, you see what's included. Well, this is included in the webinar handouts as well. And this table has maximum PV charging current, battery voltage, max input voltage, controls, operating temperatures, and it also identifies whether a particular controller has remote monitoring and data logging capabilities. So these charts are a helpful quick reference in addition to the data sheets and operation manuals to help people choose the right solar charge controller that meets their system requirements. And what you're looking at here, the chart on this slide lists our 2 smaller PWM controllers, which are the SunSaver and Sunlight. Then if we go to the next slide, we'll take a look at some larger PWM controllers, which are ProStar and TriStar PWM controllers. And then we'll go one more slide, we'll see our MPPT controllers and their specifications. And again, these tables are in your handouts, but I just wanted to go over them very quickly so you know that they're there. To finish the solar charge controller topic, I wanted to share an internal shot of our TriStar MPPT controller. So you see that here now coming up, and this has callouts that explain the many important internal components. This slide is contained also in your handouts, and the callouts are self-explanatory, so I'll let you examine this slide on your own rather than going through all the callouts on this webcast. But before I hand off to Errol, I did want to say a few words about remote monitoring and Morningstar accessories. So if we look at this next slide here, depending on your application and the personnel at your application site, you might want to remotely monitor metrics such as temperatures, battery voltages, charging stages, system current, and load run times. Through remote monitoring, you can discover when your battery voltage readings are lower than desired, or if your loads are not running. This can give you a heads up to send somebody to the site to fix problems such as dirty or damaged arrays, unexpected shading, wiring and connection issues, or battery maintenance. And Morningstar's Ethernet meter bus converter accessory, or EMC1, that you see circled in red here in this diagram, this connects the controller to an internet gateway to allow communications and remote monitoring via Modbus or SNMP protocols. And SunWize can help you set all this up with the rest of your system. So lastly, I just wanted to talk a little bit about charge controller accessories, just so you know a little bit about them and where to go to find out more information. So in addition to the Ethernet meter bus converter, or EMC1, that I talked about on the previous slide, here are other Morningstar accessories that you can use with select charge controllers. The relay driver, for example, this can initiate generator starts and stops triggered by battery voltage set points. We also have remote temperature sensors, remote meters, and adapters to connect products to computers via serial ports and USB ports. And you can read more about all these accessories at the blue link that you see at the bottom left of this slide. So now that I've covered the solar charge controllers and accessories, I'd like to hand off to Errol Rankin so he can tell you a little bit about SunWize and share more info about off-grid traffic management systems. And then also I should remind everybody, if you do have questions, just go ahead and text them in and we will address them with the application engineers that we have online with us today. So Errol, if you want to take yourself off mute and go ahead.
Thank you very much, Mark. I really appreciate the introduction and the presentation. I'm going to go here, and before I get into my portion of the presentation, we would like to take a quick poll with everybody. So I'm going to go ahead and launch that, and let me know if everybody sees the polling questions available. This is regarding how do you monitor your off-grid solar system. So go ahead and put in your answers. I will give us about, maybe another 30 seconds or so. Hopefully we can get at least more than half of the attendees voted. Our voting percentage is already quickly approaching 50%. So any feedback would be greatly appreciated. All right, give people about another 15 seconds to get your answers in. All right, looks like we've got almost 70% of the people that have voted. Thank you very much. And let me see if I can share the poll results. Hopefully everybody can see. So it looks like about 16% do it through software provided by the charge controller manufacturing, e.g. MS View for Morningstar, 8% via mobile phone applications, 17% via web interface, 6% via third-party software, and 53% none of the above. Thank you very much for that feedback. All right, so we'll cover just a little bit of a brief introduction about Sunwise Power and Battery. Sunwise as a brand has been serving remote power system requirements for industrial applications for over 30 years. We provide a variety of products and services, including turnkey systems, as well as components that support standalone power systems. Of particular note here for this market vertical is small format solar modules, which means typically nominal 12-volt 36 cell. SunWize manufactures our own line of both nominal 12-volt and 24-volt solar modules, ranging from 500 watts to 400 watts. We also support various partners such as SolarTech Power, which also has a module lineup ranging from 5 watts to 160 watts, also available in nominal 12 or 24 volts. We also, for larger load requirements or where space is not a constraint, carry standard large format commercial solar modules, which are generally ranging between 350 and 450 watts. For mounting requirements, we carry a line of side of pole mounts that support array sizes between 5 watts and 1.2 kilowatts. As well as manufacture and carry top of pole ground solutions that support array sizes from 40 watts to 5.4 kilowatts per pole. And that's in addition to other types of ground mount and other standard mounting applications. For enclosures, we manufacture both off-the-shelf outdoor rated aluminum enclosures designed to hold anywhere from a single U1 or smaller battery, which can be anywhere between 10 and 35 amp hours, up to approximately 3,000 amp hours or 144 kilowatt hours of energy storage in a single upright cabinet. We also manufacture non-glass monolithic construction solar modules that are resistant to vibration, shock, blunt force, water, and even acid exposure. These are getting increased exposure for use cases such as special shape requirements, or on things like cement mixer trucks where they may be exposed to acids and other types of solvents, or airport runway LED lighting strips where that durability is required, or OEM integration into kiosks, as just a few examples. On the turnkey system side of things, our products are usually broken down into 3 areas: standalone solar systems incorporating PV and batteries, as well as hybrid energy systems that incorporate wind energy, fuel cells, gen sets, and other baseload power technologies in addition to the solar, as well as traditional battery backup systems, which are typically just the batteries, the controls, and the AC grid input. And those are typically for critical load or traditional UPS battery backup applications. Our 2 primary warehousing and manufacturing facilities are on the East Coast and the West Coast. In addition to the services you'll see here, we really focus on designing and manufacturing a complete power system capable of running a designated load for a given climate and environment. We specialize in tailoring our solutions throughout the process to meet our customers' requirements, including layout, footprint considerations, drawing documentation and installation instructions, factory integrated components, custom device programming during manufacturing, specific manufacturing or kitting processes, shipping preferences, and much more. SunWize generally relies on our partners or end users to complete the physical installation, but we focus on making the process easy through complete documentation, versatile products, and easy to use designs. For the 24 state DOTs listed, this is for clear channels where they were either the direct purchaser or the known end user. No doubt our products are used throughout many additional states via our various client partners. So as a quick introduction, most traffic management systems being powered by off-grid solar have been focused on an emphasis around cheaper and higher quality data, as well as driving safety improvements. These images were courtesy of a road trip I took with my family last fall from the state of Oregon to New Mexico. And what was interesting to me during this trip was not only the saturation of these devices visible in roadside applications, but the prevalence in individual counties and locations, which seem to alternate between very strong and weak saturation, depending on the specific jurisdiction or area. While traffic safety is rightly a major area of focus for standalone power, the larger transportation umbrella is considerably broader and includes a diverse range of applications and research areas that we'll be talking about. So within these columns, you can see we have sort of broken out some of the major common applications and use case areas that we're seeing among transportation safety, public transportation, remote sensing, security and surveillance, as well as other applications. Now, of course, many of this is subjective and you could slide one value into another column and it would largely still be true. But I want to start by highlighting some of the ones that people are probably most familiar with that I think have the most market penetration so far. So obviously we've got portable signals and signs, which has been the bread and butter, along with crosswalk and hazard flashers, as well as street port and airport lighting, bike and bus stop shelters, local and real-time weather stations, as well as security devices. However, more digital equipment and data-driven applications are being powered by solar and improving energy storage technology, as well as ubiquitous wireless connection, at least within the contiguous United States. These are the fundamental building blocks that are filling in the holes in coverage for urban intelligent transportation systems and also expanding those into more remote locations. For example, within lighting, solar street lighting is well established and has been refined and expanded. But as an example for within ports, given the recent supply chain crunches as well as the infrastructure spending, these are all things that could factor into bringing expanded lighting to more remote or unused or new dockside locations. For both continuous and/or overnight operation, personnel recognition, asset tracking video systems, simple security cameras, and more. In the airport space, I mentioned the inclusion of non-glass metallic solar modules for LED lighting strips, as well as other next-gen technologies such as meteorological monitoring, intelligent parking management, and many other things. So what I want to highlight next is some of the more up and coming market verticals and use case applications that we've been spending extra attention monitoring and looking out for in the marketplace. No doubt there are many other niche applications in here. So if you have a good one that you feel like is not captured within this table, we'd certainly appreciate to hear what other applications may be on people's radar. For example, it was mentioned by our CEO, the monitoring of wildlife crossings for verification and validation of usefulness has been one interesting one. There's countless other ones. I heard an interesting article about potentially using smart camera scanning technology to intelligently inform users about available parking spaces. Wouldn't that be potentially nice? So when we're thinking about the broader intelligent transportation systems and IoT world within the transportation umbrella, to us that largely expands not just to traffic, but also pedestrians, rail, airports, ports, border crossings, and others. This diagram that you're looking at, as well as the electronics on the right-hand side, are courtesy provided of Lanner Electronics. I think this is a good diagram to show the interconnectedness of some of the next generation technologies that will be relying at least somewhat on standalone power for use cases when grid is unavailable, impractical, or too expensive. And you'll notice also some of the use cases spoken to about these basically edge computing devices for intelligent transportation, as well as AI and automation, ranging from fleet management to environmental monitoring and lots of other applications. So just to give people a little bit of exposure to some of the things that are driving this in the background, here's a couple interesting articles within the last 2 years covering anything from researchers focusing on roadside LiDAR sensors to further improve transportation safety, to mayors asking for specific funding for automated license plate readers to help reduce highway crime and other things, as well as research projects using solar power, sensors, and Arduino Raspberry Pi controllers meant to economically and efficiently monitor bridge safety as well as other forms of structural integrity. So with the recent passage of the infrastructure bill, there is approximately $550 billion earmarked for new spending. I have taken the subset that has been, readily reported on in the media. You can see the article I pulled specifically from. The breakouts of the sectors that I think are going to be most likely to benefit from the possible inclusion of remote power systems to drive some of the more advanced digital architecture that we've been talking about. Of course, that includes roads and bridges, railroads, public transportation, airport modernization, ports and waterways, as well as transportation safety. So within this, we run into from time to time Buy America, Buy American requirements. And there's only a couple things that I really want to highlight here. SunWize would certainly not claim to be an expert on this sort of stuff. There are plenty of lawyers and consultants who specialize exclusively in this area. And of course, there's a lot of considerations. But at the end of the day, as a integrator or as a procurement business, you may be called upon to meet certain Buy America or Buy American standards. And so to at least be aware of what some of the nomenclature and terminology is, I believe can be very helpful and important. So just as an example, you'll perhaps notice the red N on the Buy American title. That is not a typo. There are differences and different programs around Buy America versus Buy American, as well as differences both legally and just in terms of understanding between made, manufactured, and assembled within the USA. So to begin to understand this, to be able to navigate effectively via various procurement requirements that may change broadly depending on which exact location or entity you are selling into. As an example, we just entered an order into our system today, which required some internal review on a very specific FAR 52.225-1 requirement that was driven from some purchasing funding requirements from the USDA. So it's definitely out there. The important point that I would like to make here is that SunWize's domestic manufacturing capabilities, largely around our sheet metal products, mounts, and enclosures, coupled with domestically manufactured batteries, as well as balance of systems and final integration assembly, is often able to get over most of the required Buy American system procurement requirements, which can often be driven off of a certain percentage value threshold of the overall assembly, for instance, 50%, 60%, 75%, so on. So no presentation from SunWize would be complete without a cursory reference to understanding loads. All projects really start with understanding the load profile of the device to be powered. I'm sure no one here has made this mistake, but it bears repeating why a 100-watt solar module will not power a 100-watt continuous load. A couple of the reasons are, of course, that storms happen. Night comes every day. We also have season affective disorder where there's less sunlight in the winter. And if you did, you wouldn't need batteries for energy storage. So we work with clients every day to determine and analyze equipment loads. Well understood loads are the first step to a reliable standalone solar system. And sometimes those loads are not clear. Sometimes we're only presented with a data sheet that may list a minimum power or a maximum power, and that could be a broad range. At the end of the day, there's no substitution for good field-driven data. That is easily something that can be accomplished with the onboard data logging or remote monitoring capabilities provided by Morningstar charge controllers. So running a pilot project to understand real-world loads, if you don't actually know, can be helpful or very helpful depending on the specific project and the volume and so on and so forth. We also want to bring awareness to a point Mark made earlier around the DC power and the advantages of staying on that side of things. Solar systems inherently are DC power because the energy coming out of the solar module is DC, as well as passing through this charge controller and stored in the battery. Therefore, any industrial equipment that can run in this nominal 12, 24, 48 volt DC range, which is typically approximately 10 to 72 volts DC, is going to have the advantage of not having an extra point of failure with an AC inverter, as well as benefiting from not having the efficiency losses, which can range anywhere from probably 7-8% up to 15 or even close to 20%, depending on the exact inverter used. I'd also highlight that when working in standalone power applications, low power consumption devices can make a huge difference. Oftentimes, a specific device that was originally intended for grid-tied applications may not be thinking about efficiency much because the cost of power when connected to the grid for these types of devices is often negligible. However, if it's possible to use an equivalent device or something that achieves the same function but with a much lower power draw and more efficient design, that will save you significant money for standalone power applications, because at the end of the day, the cost to run a continuous standalone off-grid load is roughly linear with the size of the load. And then one other thing that is kind of especially prevalent in traffic as well as power over Ethernet applications is that sometimes we don't really understand the load circuit particularly well. And so do think critically about what is the end device actually being powered, what conversion adapters does the manufacturer provide by default, and when you think you need AC, maybe stop and ask one more time, is the end device really still needing AC, or is it possible that we could provide a DC option or bypass that inverter entirely? And these are the sort of things that we'll be asking when you work with us to make sure that we're not losing opportunities to have a more efficient design. All right, so the next thing we're going to talk about is product certification and listing requirements. This is a broad topic. We're certainly not going to cover everything there is to discuss on this topic. I will leave you guys with a few important notes that I think are relevant to take away. The first is that I've included a link to the UL Whitebook. As people that have worked with standards and certifications know, it's not particularly light reading. It's over 1,100 pages. I did a quick Control F for solar. It's referenced 127 times. And the important thing to keep in mind is that these certifications, listing requirements, regulations are enforced at the local government AHJ level. The National Electric Code defines an AHJ as an organization, office, or individual responsible for enforcing the requirements of a code or standard or approving equipment, materials, and installation or a procedure. So when you are discussing various requirements, we had a pretty humorous one for us recently. It's not the first time that we've heard it. Hey, what listing do you require for your project? It just needs to have UL. There is not a magic UL certification, unfortunately. And sometimes if there's a sticker or any UL certification, that may be good for the end user. But really, at the end of the day, some of the commonly requested certifications that we see line up for the common components are UL 1741 for solar charge controllers, which Morningstar has, I believe, on the majority of their lines. I'm not sure if it's every single one. We can clarify that, but that's a go-to for us. On the solar module side of things, you'll frequently see UL 1703. That's another good indication of not only the potential use of that product within a lot of these applications, but as well a reference to the quality and build construction of the product itself. On the enclosure side of things, you may have UL listing requirements, NEMA listings, IEC, ATEX, and that's one where it can really run the gamut depending on the specific project or application, or whether you're working domestically in the US or abroad in European or international markets. Sometimes you may need a UL recognized component. A common example for us would be a lead acid battery. Namely some of the ones that we use regularly from MK Deca, their gel and AGM monoblock series are both listed as UL recognized components. And then last but not least, we have inverter and energy storage system requirements. There are many out there. Some of the more prevalent ones gaining traction right now, especially in the California market, are UL 9540 and 9540A. I've included a couple references to some lithium battery partners that both SunWize and Morningstar work with, who have recent announcements about their passage of either 9540 or 9540A. That includes Fortress Power from October 2021, as well as Simplify Power from December 2021. And if you are one of the folks that is working with inverters and UL requirements for advanced energy storage systems, particularly in the state of California, then we feel your pain. All right, so the next thing I want to talk about is wind speed requirements for mounts. This is another very strong topic and requirement area within the transportation sector. I'll start with a couple things to consider. So the most common standalone solar mounting method is to a pole. Solar arrays are essentially big, rigid wind sails that are designed to stay in place. And they are often in proximity to pedestrians or high-risk areas. So you put those three things together, and this is an area ripe for needing robust requirements around the wind speed loadings on various mounts. So I'd like to speak a little bit to the certifications and design considerations that are behind our SunWize side of pole mounts, as well as some of our partners as well, but these standards are specific to us. So our certification design parameters are based around both IBC, the International Building Code, as well as ASCE 7-16. Our design rating ranges are defined on a 3-second gust wind speed, approximately 100 to 150 miles per hour. That range is because of the various considerations listed below. So that includes what tilt angle the array is positioned at. This is a degrees from horizontal reference, as well as the ground snow load rating for the location, typically given in pounds per square foot. PSF can range from 0 to 60 often. The wind exposure category, in our case, we've based it off of category C. However, there are also categories A, B, and D. Category C is considered open terrain with scattered obstructions having heights generally less than 30 feet. The other major consideration is going to be height above grade. So the higher you go above ground level, the faster the wind speeds generally are. And then you have the pole size diameter given generally in Schedule 40. And then you have soil conditions, and then beyond that, seismic zone consideration. So many, many things that go into determining a valid certification requirement for a mount. Now, taking this one level deeper, you have different types of requirements. So you may need a general certification. You may need designed in accordance to. You may need a general PE stamp reference to the design. That PE stamp may need to be within the specific state of the project, or that PE stamp may need to be specific to the actual project at hand. We have seen all those depending on the exact requirements and location. So looking at what these wind speed rating tables comprise of, this is specifically for our one module large format side of pole mount. It comes in 2 pole size configurations, 4 to 6 inch, as well as 6 to 10 inch. You'll see the 2 part numbers for each respective pole size there above the graphic. And looking at these 4 tables, you'll see in the upper left-hand corner, we have that's the tilt degree angle. So different results, whether it's at 30, 35 degrees, 45 degrees, or 55 degrees. Then looking at the rows, you'll notice that is the rated ground snow load reference in PSF from 0 to 60. And then in the columns, you'll notice that we have the various checks on whether the design is valid, as well as what pole size that valid design is around for wind speeds between 100 and 140 miles an hour in this case. So again, green is okay. The values within the table are the pole diameter in Schedule 40 inches, and SunWize within our broader product portfolio is able to achieve 100-mile-per-hour certified wind speed ratings from approximately 40 watts to 1.2 kilowatts for side of pole arrays and up to 5.4 kilowatts per pole for top of pole arrays. Okay, circling back to the topic on remote monitoring, I wanted to add a few additional things. So at the top, you'll see a relatively simplistic diagram. I would go so far as to say perhaps the most simplistic diagram you can get for a basic remote monitoring connection. So in this case, we have a Morningstar solar charge controller with remote monitoring capabilities. That connects to a gateway device or a cellular modem, which connects to common cell carriers via SIM card. That could be any one of the national telcos, Verizon, AT&T, or it could be more industrial focused data providers that do lower data package plans and are primarily focused on machine-to-machine communication. Some of the major reasons that we wish to remotely monitor solar systems are, of course, to get visibility on alarms and faults as soon as they happen. The big one, of course, is monitoring battery voltage, which really is battery health in a lot of ways, as well as the overall system performance. Is it performing as designed? Is it having issues? And of course, remote troubleshooting. For those of you that have had the pleasure of trying to fix a solar system, it's unfortunately often when you don't want to be doing it. The weather can often be cold or blaring hot, and generally being hunched over a laptop in the field is not the most enjoyable experience. So being able to do that remotely and get a good grasp on the overall system can enable you to come out to the site once instead of twice, because you know what's required to fix the issue on the first time. Sometimes it can even be resolved remotely. And then one of the other important things here that we mentioned on our poll is feeding this data into larger fleet management or control centers. Because of Morningstar's open source philosophy and using base Modbus SNMP architecture, this is eminently doable by any entity with a little bit of networking capabilities. So that can be an incredibly powerful tool to take all this data for large volumes of systems and bring that into your ecosystem where you're already looking at and monitoring information for your core competencies. For example, the traffic systems themselves, or in other market verticals, it may be the camera data or the RTU information from the wellhead, so on and so forth. There's 2 major options here within the Modbus side of things. There's TCP/IP Ethernet that happens via the EMC1 accessory, as well as Modbus RTU, which can happen through serial RS-232 or EIA 485. There's also master slave opportunities within Morningstar architecture, so that if you would like to monitor more than one Morningstar device within a system, you can do that through a singular gateway point. All right, so here's a little overview on some enclosure assemblies and wiring. What are we talking about here? What does a real system look like on the inside to power some of this equipment? So the photo on the right is courtesy of Eltec Corp. This is an old generation system using the now discontinued Eltec FS3 DC flasher controller module, as well as the discontinued Gen 2 ProStar. Has since been replaced by the Gen 3 that we covered earlier on the presentation. On the left-hand side, you'll see basically a newer design pilot system that we currently have out in Florida for testing. That's moved on to a simple sun saver. It will have the next generation FS4 Eltec flasher, which I think in this case was being integrated by our client partner in this case, just to give you guys a feeling of what some of the internal controls may look like. Of course, really it runs the gamut depending on what specifically you're powering, what the size of the load is. This is just one representative example. There's far too many to cover for the broad range of applications within the larger transportation industry. The last things I want to cover is today's webinar actually officially marks the initial launch of a new SunWize standard traffic enclosure product, our part number 260051. After much discussion with many of our partners, as well as various end users and market research, we came up with a broad use set of design features that we think cover the largest area of requirements within these various certification design standards needing to be met for various projects. Some of the biggest ones include 3-point stainless steel latching, a broad range of mounting to different pole diameters, which on a given project can be quite varied, a continuous stainless steel piano hinge, mounting studs to fit our standard control panel backplate sizes, which makes integration easy for either SunWize if doing the complete turnkey system, or for our partners if they're taking on some or even all of that integration scope of work themselves. We've got knockouts at the top of the enclosure for easy access, a removable shelf, which can be used when needed for the extra energy storage. And this enclosure is designed to fit up to 2 Group 31 batteries, which is about the standard large automobile battery car size, approximately 100 to 125 amp hours per nominal 12-volt battery. So just to summarize and wrap this up, we're focused on power for transportation projects and devices. We have both off-the-shelf systems that are designed for quick and easy fulfillment, usually shipped within 1 week or so. And these are great for simple load applications under 60 watts continuous. And that can be DC or AC within that Power Ready Express line. We've also got our custom standalone turnkey systems, which are really tailored to any customer requirement there may be. We've got hybrid power systems, which incorporate some of that other baseload technology that we discussed, wind, fuel cells, generators, so on and so forth, as well as the core components that make up all the building blocks for the systems that we've spoken about. And then, of course, the design and support to make sure that your project is successful. So we have about 10 minutes left on the presentation. We wanted to make sure to leave some time for some question and answers, given the team that we have available. It seems like there are a handful of questions in here. So Mark, I'm going to turn it back over to you, and maybe we can go through a few of these questions. If you have any further questions from the presentation, anything that you'd like to know, feel free to shoot it out there. Even if we don't get to your question specifically today, or if it's one that we need to take online, having it there in the chat is going to be helpful. We can follow up with you and dig in on whatever you may need to know.
Okay, good. All right, thanks, Errol. Great presentation. Yes, we do have a number of questions that come in. This one's a really good one. I bet you it's on a lot of people's minds. Question is, how does your system handle wet snow or freezing rain that can stick to the glass, making the traffic light invisible? The traffic lights connected to the grid warm the lenses. Is this possible with solar? And Kyle, one of SunWize's application engineers that's online, texted an answer. Kyle, if you want to go ahead and take yourself off mute, and if you could answer that question for the entire audience.
Yeah, so with that, it really comes down to the heating for the traffic light is considered a separate load, and we'll need to take that into account when sizing the overall system. It's something we can do. It just needs to be accounted for when you do your initial sizing.
Okay, terrific. So that's a great question, great answer. I see another question here that I guess this one's probably on a lot of people's minds too. The question is, in what temperature range can your system operate? For example, can it hold enough battery reserve to operate at -15 Fahrenheit for 4 days in a row without sun with a single traffic light? And I believe, Kyle, you texted an answer to that one as well. If you can go ahead and let people know the answer to that.
Yeah, so our standard systems, when we do standard design, is for 5 days of autonomy with no solar input. And we have components that are capable, we can design a system to be able to go down to -40 F between batteries, charge controllers, and all the components. And so we can size that properly for that 5 days of autonomy.
I'll add one more thing onto that, Kyle, as well. Battery design and everything that goes into that is a whole presentation worth of content. I encourage people to go to our website. Under our headers, we've got a tech notes area. The one thing that I will say is that batteries lose energy storage capacity with lower temperatures. So basically, the lower temperature it goes, the lower usable energy you have in the battery. So on the extreme end of the case, I can recall a couple projects that we've done in like Saskatoon, Canada, for instance. You can have a multiplier to be able to have an amount of energy storage at -40 F that you would have at ambient can be as high as a 16x multiplier. So eminently doable, but it can be a very large multiplier at those extreme temperatures.
All right, good info. Here's a question. Do you have traffic light systems installed in Canada? And Garrett answered that question. One of SunWize's application engineers. Garrett, if you can take yourself off mute, if you're able to address that question.
Yes. So we do have systems in Canada. I am not positive whether or not they're a traffic specific system, but we do have systems installed across Canada with taking considerations for temperature, lighting availability, and all of those kind of considerations.
All right, very good. All right, here's a question from Jason. It reads, will a solar charge controller work with a digital power over Ethernet? And I believe Kyle answered that one. If Kyle's able to
Yeah,
take it.
so we can, by itself, it will not provide PoE, but we do have PoE injectors that we can provide with our systems and integrate, and that can work with whatever PoE protocol you're using.
Okay, very good. So ultimately, with the PoE injections, you can facilitate that. So terrific, great question. Let's see. Question from Robert. Let's see. Okay, we made some comments about Buy America and Buy American. Do your systems meet these requirements? And I believe Grayson answered that question. If you want to take yourself off mute and let us know the answer to that.
Yeah, sure. We do our best to get as much as we can American made, and we definitely do all the manufacturing here in the US. But some things, some electronics are just tough to get nowadays. So every once in a while we have to dip out, but we can usually meet your needs.
All right, very good. Let's see. Question coming in. It sounds a long one. Make sure I read it correctly. All right, let's see. No shade layers on the battery cabinet to keep direct sun off of the top setting sun side. No point to set it above grade is set on connect in case of snow or ice at bottom. I do see Grayson looks like he had the chance to decipher this and answer this question. Can you share us, Grayson, your answer to
Yeah,
literally
sure.
a
I
statement or a
was really
question?
happy to see this one actually, since we're getting lots of feedback on this enclosure and working on it as we go. I just was pointing out that this is the base enclosure that covered most cases, but we're totally happy to add some shade layers or customize the enclosure as needed.
In
Okay, so
general, we will entertain custom enclosure design requirements. We do that frequently. Obviously, unit one for a not expensive custom enclosure is probably not going to be great, but if you're talking something in the 20, 30, or certainly 50 plus volume range, that's usually when entertaining a custom design is something we'll be happy to work with you with.
okay, hey, here's a great question that came in. I was hoping somebody would ask this. Let's see, it looks like Jonathan's asking this. What kind of battery life is expected before replacement for these outdoor installations with their uncontrolled enclosure temperatures? And I think Grayson handled that one as well.
Yep. Another fun one to answer. It generally it's hard to answer in a general time. It's hard to say, oh yeah, for sure you'll get 2 years under these conditions, because it just depends on the battery manufacturer, like the quality, I guess. There's varying degrees, and then also just the temperature extremes you experience. And I was just trying to say in general, you know, if you're in the cold, cycling in the cold a lot, like below zero, you're likely to see less, and same in the extreme heat, you're likely to see more derate or degradation of the battery over time. But tough to say an exact time.
I'll venture out and put my neck on the chopping block here and at least give something. I would say that for lower cycle life rating batteries, we often look at cycle life at 50% depth of discharge. So if you've got a cycle life at 50% depth of discharge in the 400 to 600 cycles range, maybe call it a 3 to 5 year battery. And that's pretty much in relatively normal conditions, not assuming it's a poor design or disconnect between loads or anything else. For the more premium cycling batteries, typically rated for 1,000 cycles or more, 50% DOD, you're hopefully looking in the 4 to 7 year range, maybe 5 to 7 years. So those are very broad stroke answers, but hopefully that at least gets you something. If you put a really cheap battery in a poorly designed system out in Texas with extreme heat, see this all the time, you may be replacing your AGM batteries every year and a half. So it can really run the gamut.
All right, very good. Thanks for answering that. Question coming in, are your systems or do your systems meet standards in Canada, for instance, CSA and ULC?
So
And
our
looks like
systems,
Kyle
oh,
can answer that.
so our systems themselves are not CSA or ULC rated listed because they are custom built, and it's a big process to get the whole system rated. We can use CSA rated and ULC listed components inside the system.
Yep, and I would say again, same sort of thing with the custom enclosure. There are a few select projects where we are exploring or entertaining those system level certifications, but they're generally for much larger volume design needs where the client has a very specific use case requirement for that. It's doable, it's not easy or fast.
All right, very good. I think I'll take this one. Mike's asking, is there any conformal coating on the controller PC boards operating in roadside salt-rich environments? So the answer to that would be yes. The Morningstar controllers have conformal coating and epoxy encapsulation. So yes, for that exact reason and other reasons, not only roadside salt, but other regions of the world where our controllers go. There's all types of dust and other debris and contaminants that we want to protect the PC boards from. So thanks for that question. Let's see, a question coming in from Kirk. Let's see. Why doesn't SunWize carry? Wait, that's a certain brand name. I better let me take that one offline, or let SunWize take that offline. I'm not sure about that one. Let's see. Okay. I'm looking at, does an off-grid system withstand an EMP?
So I love this question. I
Yeah.
have no idea, honest answer. I would defer to the rest of our engineers, but I know of at least one person at our company, probably a few, who would be really excited to run this test. So if we can figure out how to run it, we'd certainly be interested in exploring it. We've got an ongoing joke with some of our colleagues around EMPs and what can withstand what, but I don't know. We've never read an EMP test yet. Any of the engineers want to take a hazard a guess, add on to that at all?
Or I'll throw this out there. I know that we at least have one member on staff that is taking a personal project on the EMP subject, and I also know that there's some vendors that we've worked with that do advertise EMP hardened components, but I would say that more research has to be done.
Okay, very good. I'm looking at some other questions that came in. This was a long one. Let's see. Okay, let's see if I can decipher this. Okay, coming in from Gail. Question is, I have an off-grid site which owner reports the front meter screen. This is the TriStar 45 PWM, which has started to flash alarm, but the screen will not advance to other screens, which give specific details. The charge controller function seems to be still working. What items should I take along for a site visit to troubleshoot versus just switch out? Anyone have any thoughts on this?
So I guess the first thing is the screen you're seeing is actually the meter display. And so the alarm error may show up in the meter display manual. The TriStar will actually change its LEDs based on what alarm it's experiencing. So in the TriStar manual, there'll be some error codes for different flashes of the LEDs that will give you a better idea about what is happening on the TriStar. When I would head out there, I would just make sure you take a multimeter so that you can measure voltages and check continuity, and bring your manual so you can see what those LED indications are.
Kyle, do you think a USB one could be helpful as well?
Yeah, that's also a possibility. If you take a laptop out there and the UMC1 adapter from Morningstar, you can hook your computer up to it and pull up the errors and see more data from the controller itself.
And that would happen via the MSView program, right?
Yes.
Which is free, provided by Morningstar. You can download it easily online.
Great point. Great points, I should say. And thanks for that question. Let's see. Oh, okay, here's an interesting one. Let's see, do you have some systems installed with solar fuel cells combined, solar and fuel cells combined? Let's see, it's interesting to see if they could work both together.
Great question. I'll go ahead and jump in on this. So we actually have a test system here in our Oregon facility with a fuel cell installed. So we've been testing it internally for quite some time. I would say in general, the market penetration is still a little bit slow on the uptake for the various small power form factor fuel cells. However, they're definitely out there, and we work with a few partners closely. There's no inherent reason that I understand that they're not great use cases for traffic applications in general. And one of the areas that I see the most possibility, well, there's actually a few, right? So we talked about low sun environments like Canada and other places where you may have both these cold environments that significantly affect your battery capacity, as well as really low sun in the winter. Those can be great, obvious options for inclusion of fuel cells. In the past, maybe they've run generators, but now you've got these relatively small, oftentimes rack mountable fuel cells that can be a great potential in those sort of applications. The other one that comes to mind for me is in traffic and transportation applications. It's one of the places that I most frequently see space constraints. So you're wedged in a specific place in a highway, you only have so much footprint, and solar, the power really scales linearly with the footprint. And as these loads start to get relatively large, you can be talking about pretty big solar arrays, quickly starting to take up significant ground mount space. So if you really need a load and you're really constrained on available space, and you want a clean next generation solution that doesn't have maintenance requirements and some of these other things, then small form factor fuel cells can be a great option. And they kind of can come in power building blocks from as little as 50 watts continuous, quite small, and then going up to 100 watts, 500 watts, and then 2.5 kilowatts, and then 5 kilowatts. So there's a pretty broad range of commercially available fuel cells ready and have been seeing deployments anywhere from 50 watts to 5 kilowatts of baseload power. And I would say, yeah, they're a great solution. I'll actually be presenting at a conference in October specifically for the utility and the environmental monitoring section that has a whole fuel cell track for these applications, and I'll be speaking largely about fuel cells in my presentation. So very much an upcoming technology. I also have a background in fuel cell research, so I really am interested in it as well. So.
All right, very good. Thanks for that question and answer. See a nice question coming in here that reads, have you done a lighting system with a load greater than 5 kilowatts using LED luminaires? Do you have a general budgeting cost for a system like that, not including the cost of poles, luminaire, and wiring?
I'm just going to go ahead and say I don't think we do offhand, but I believe that we can get Alan and perhaps a few other folks on our team to potentially put something together on this. Alan, do you think this is something that we might want to take a stab at?
I don't see a reason why we wouldn't. I know that, lighting.
We'll be happy to follow up with you on that, but I don't have a good answer off the cuff.
Yeah.
Okay, it looks like I think we've covered everything in here, and it looks like Kyle followed up again with Gail with her some of her questions about the TriStar PWM meter and the alarm. So I think we've covered everything. Anyone see anything that we haven't covered, or anything come to mind that we should share before we sign off?
I don't think so. Contact information is here. So if you think of something after the fact, please do not hesitate to reach out. And I just want to give a big thank you for everybody for attending, as well as so many folks staying almost 10 minutes over for what I thought was a really good question and answer session. So thank you all for the great questions.
All right, likewise. Okay, so what I'm going to do, thank you, Errol, and thanks to the audience, and thanks to the SunWize application engineers. Terrific job. And again, you'll get a recording of this webcast tomorrow by email. So I'm going to close things out. We'll see you next time. Thanks very much. Take care.
Thank you all.